A warm welcome to All4Chem chemistry channel. Today in this video I am going to talk about an important topic in chemistry, which is chemical bonding. Let us see first the key points of this session. The key points are, first one is define a chemical bond, and the second one, reason behind bond formation. Okay, let's begin. Yes, I hope all of you are familiar with the word bond. What do you mean by the word bond? For us, it is a relationship. We used to tell about friendship bond and family bond. A friendship bond means the relationship between two friends, and the family bond means the relationship between family members. Here you can see a family picture, parents and their children. Here in this family, the healthy relationship between these family members creates a bond, and this bond makes the family members stable and happy, right? Similar is the case with chemical species in chemistry. Let us take sodium chloride as an example. So sodium chloride is NaCl. Its chemical formula is NaCl. So here you can see atoms of two different elements, sodium and chlorine, right? So the question arises, how do the atoms of these two different elements remain together as a single species? There should be some connection between sodium and chlorine, right? And we call this connection as chemical bond. So chemical bond is a force that holds the constituent particles together in a molecule, right? So how can we define a chemical bond? A chemical bond is the force of attraction that holds the constituent particles together in a molecule. The constituent particles may be atoms or ions. Then the next question arises, why do atoms enter into chemical bonding, or what is the reason behind chemical bonding? To find out the answer, let us have a look at the electronic configuration of inert gases or noble gases. These are the inert gases: helium, neon, argon, krypton, xenon and radon. These are their atomic numbers, and these are their electronic configuration. So if we closely look at the electronic configuration, we can see 8 electrons in their valence shell. There is an exception case, that is helium. In the case of helium, there are only 2 electrons, but still with 2 electrons, helium is stable, and this condition is known as duplet. Other than helium, all the other elements have 8 electrons in their valence shell, or we can say they have octet electronic configuration. Octet means 8. So due to this octet electronic configuration, noble gases are stable. That is why they do not take part in chemical reaction. That is the reason behind their inertness. Okay, so all the other atoms enter into chemical reactions to attain stability. How do they attain stability? By achieving the octet electronic configuration in their valence shell. Valence shell means the outermost shell. So if an atom attains octet electronic configuration in its valence shell, you can say it is stable or happy. Right? So this can be generalized as a rule which is known as octet rule. The octet rule says that atoms enter into chemical combination to attain stability by achieving octet electronic configuration in their valence shell. So in the case of sodium chloride, sodium and chlorine enter into chemical bonding to attain stability by octet electronic configuration in their valence shell. So how do they reach this octet in their valence shell? There are different ways to achieve octet electronic configuration that we will discuss in later classes. Okay. To quickly recap, I would like you to remember these key points. What is the chemical bond and what is the reason behind chemical bond formation?